Hello and welcome back to Duffy Science. Today we will be looking at nuclear energy, and more specifically, can I explain how nuclear fission works? So what is nuclear fission? Nuclear fission is when we take the nucleus of an atom and cause it to split, releasing huge amounts of energy. Nuclear fission releases over 1 million times more energy than a normal chemical reaction, making bombs that can destroy whole cities in one go a reality. So before we move on to the steps, have a quick look for your exam board so you can see how today's video fits in with your learning. So in order to understand nuclear fission, you will have to be able to recall the structure of an atom, outline how a neutron can be used to split an atom, describe the fission of a uranium nucleus in detail, and finally explain how a nuclear chain reaction occurs. And so, on to step 1. Can I recall the structure of an atom? So here is an atom. It has a central nucleus containing protons and neutrons, and then orbiting around the nucleus are these smaller particles called electrons. Protons have a positive charge, neutrons have no charge, and finally the electrons have a negative charge. When talking about nuclear energy, we're only really concerned with the nucleus, as the electrons are not involved in this process. Now just an extra bit about the charges, which will be important later on. Like charges repel each other. This is because there is electrostatic repulsion. Opposite charges attract each other. This is because there is electrostatic attraction. Now on to step 2. Outline how a neutron can be used to split an atom. So here are the nuclei of two different atoms, carbon on the left with 6 protons and uranium on the right with 92 protons. Only heavy nuclei like those of uranium undergo fission, as the fact there are 92 protons repelling each other makes it very unstable. Two isotopes in particular are unstable and are the main ones used in fission. These are the ones you need to know for your course. They are uranium-235 and plutonium-249. They are said to be fissionable. So the uranium nucleus is ready to split, but how do we actually make it split? This is where the neutron comes in. If we fire a neutron at the uranium nucleus, it will make it unstable and cause it to split into daughter nuclei. So, what are these daughter nuclei? They are the nuclei of other atoms in the periodic table. In this example, a uranium nucleus is split into barium with 56 protons and krypton with 36 protons. 56 and 36 is 92. Another question they like to ask in your exam is, why is a neutron used to start a fission reaction and not a proton? Well, let's have a look here. A proton is positively charged, and the uranium nucleus is also positively charged. And what happens to like charges? They repel each other. So the proton cannot strike the nucleus. But where does the energy in nuclear energy come from? Well, let's have a look at these daughter nuclei again. Both the daughter nuclei are positively charged. And what happens to like charges? Well, they repel each other, and fast. How fast, you may ask? At 9,000 kilometers per second. That's 3% the speed of light. To put that number in some kind of context, that's fast enough to travel from London to Los Angeles, a flight of 11 hours in just 1 second.
Holy moly!
In a nuclear bomb, when you have trillions of these fragments bashing off each other at 9,000 kilometers per second, the center heats up to hundreds of millions of degrees, and this causes the huge explosive release of energy. Now, it's all well and good you understanding nuclear energy, but what type of questions will they ask in my exam, and what do I write to get the marks? Typical questions might be, outline how a neutron causes nuclear fission. And you would write, a neutron strikes a nucleus, making it unstable and causing it to split into daughter nuclei. Explain why a neutron is used to initiate a fission reaction and not a proton. A neutron has no charge, so there will be no electrostatic repulsion with the positively charged nucleus, so it will be able to strike it. Or you might be asked, explain why a proton is unable to initiate a fission reaction. And your answer will be kind of the same as the previous one, with only one or two words changed. A proton has a positive charge, so there will be electrostatic repulsion with the positively charged nucleus, so it will not be able to strike it. Now we have the basics. The rest of the steps are actually pretty quick and easy. So on to step 3, describe the fission of a uranium nucleus in detail. So we've looked at the fission of one uranium nucleus in detail, but in a nuclear bomb there are 10 trillion fissions, all in a split second. So how do we go from one fission to 10 trillion? So there's one extra piece of the story that we haven't covered yet. The start is the same though. When a neutron strikes a uranium nucleus, it makes it unstable and causes it to split into daughter nuclei. But as well as these daughter nuclei, we get these extra neutrons called secondary neutrons. These secondary neutrons are then free to strike other uranium-235 nuclei and cause them to fission. So in your exam, if you are asked to describe the fission of a uranium-235 nucleus, well, the first part of your answer is the same as in step 2. A neutron strikes the uranium-235 nucleus, making it unstable and causing it to split into daughter nuclei. And then you just add on, and secondary neutrons. And now on to today's final step, explain how a nuclear chain reaction occurs. So this picture should now make sense to you. A neutron causing a uranium nucleus to split, and then the secondary neutrons at the bottom causing more uranium nuclei to split. Well, let's say that 3 uranium nuclei at the bottom each release 3 neutrons. 3 times 3 is 9, so that's 9 fissions, and then 27 fissions, and then 81, 243, and growing to a huge number of fissions very quickly. And that's what we see in a nuclear bomb. The fission of one uranium nucleus causing the fission of trillions all in a split second. I did that last part myself. So when something grows very quickly like this, it's called exponential growth. So that's it. That's a nuclear chain reaction, when one fission causes many other fissions, releasing a huge amount of energy. Buildings and cars tossed around like they're toys. So again, what do I write in my exam? Well, the answer is the same as steps 2 and 3, you just add on this extra part in green. These secondary neutrons then cause other U-235 nuclei to fission, and the chain reaction grows exponentially. So that's it, you know nuclear fission, but don't go anywhere just yet. I have some extra tips for you that will really help you in your studies. So how do I really solidify my learning? You could go to duffyscience.com and download the notes that match this video. They're free! You could make your own notes, flashcards or mind maps, or whatever works for you. Everyone's different. You could practice some book or exam questions to see what style of question you will probably have to face in the summer. You could watch the video again, but this time pausing it regularly and see if you can predict what I'll say next. And finally, and I really like this one, teach it to a friend. That way you can be really sure that you understand it. But just remember, when not watching videos, you should really be putting pen on paper when you're studying. And finally, if you're stuck, you can email question@duffyscience.com and I'll get back to you as soon as I can. All the best and see you in the next video.